In today's episode of SubstituShow, we're going to learn about integration by substitution. So what is it all about? Sometimes we encounter a more complex function like this. The integral of quantity x squared plus 4 squared, 2x dx, which cannot be integrated with just simple indirect anti-differentiation methods. So at first glance, this equation looks hard to integrate because we would have to further expand the equations inside the parentheses and further multiply it by 2x. And then we can finally integrate it. But actually, there is a shorter and quicker way to solve this. And that is through integration by substitution, or the u-Substitution. We learned from differential calculus the use of chain rule, where if h of x is equal to f of g of x, then when differentiated in both sides, h prime of x is equal to f prime g of x times g prime of x. So why is it called u-Substitution? It means that we are going to rewrite the whole integral in terms of a new variable, u. Back to the problem, the first step is to pick your u expression. U expression is almost always the longer x expression in the integral or inside some forms like a square root or a power. What will always be true in using integration by substitution is that the integral will have some function and the other part will be the derivative of that function. If you would notice, 2x is actually the derivative of the equation inside the parenthesis, which is x squared plus 4. We then make the equation inside the parenthesis as the u expression. Setting that as our u, we proceed to the next step, which is looking for the differential, which means the derivative of u with respect to x, which is du is equal to 2x dx. Now we're ready to substitute everything completely in terms of u and du. Remember that u is in place of x squared plus 4 and du is a substitute of 2x dx. Plugging in u and du, we get the integral of u squared multiplied by du. From here, we could see that the equation is much easier to integrate and we could just apply the power rule. Applying this rule, we get u cubed divided by 3, and since this is an indefinite integral, which means there are no limits, we add c. What happens to du? It just disappears when you integrate. You can think of it as undoing the chain rule so it goes away. Finally, you substitute the u expression back to what you defined it to be, which is x squared plus 4. So for the final answer, we get the quantity of x squared plus 4 cubed divided by 3 plus c. Observe the example, the integral of 6x sine quantity of x squared plus 3 dx. And applying what we have learned from the previous discussion, we pick the expression x squared plus 3 as the u. However, observe that its derivative, or the du, which is 2x dx, does not exactly match with what you have left in your integral. For this equation, we have to manipulate or rearrange the u or the du to make the substitution easier. As said earlier, we have u equal to x squared plus 3 while the du is equal to 2x dx. We can multiply the du by 3 so we get 6x dx, which matches perfectly with the remaining integral equation. Now we substitute in terms of u and du, so we get the integral of sine u cubed du. Seeing the substituted equation, we can easily integrate it. We know the constant 3 should be pulled out and the integral of a sine function is negative cosine, so we get 3 multiplied to negative cosine u. By substituting u to the original expression, we get negative 3 cosine quantity of x squared plus 3 plus c, which is the final answer. So for today's lesson, we learned about the integration by substitution, reviewed the chain rule, answered why it's called the u-Substitution, enumerated the steps for integration by substitution, and answered some sample problems. That's all for today's episode. I'm Zyra Abellar. This is SubstituShow. See you next time.